Probably what I think I'd like to concentrate on and probably bring some value to the discussion is, from the consultant's point of view, explain our BIM journey a little bit, and where we've seen efficiencies gained through BIM from the design through construction. I'll start in the time-honoured self-deprecating form. I'm not a BIM technical person, but I have been involved in the process of delivering projects enough to see the benefits and probably talk to those. So my presentation is going to cover a case study, and I'll come to that and go away from it, come back to it again as a theme. The Telstra Clayton Data Centre, which Warwick Stannis from AECOM has mentioned earlier. We've been involved in that project for 5 years. 2 years in early stages of design. The last 3 years has been 3 years of a 4-year delivery contract from our point of view. In the early days of our BIM development, I think it's fair to say that AECOM, probably like most, operated in an island BIM capacity, and then over time our collaboration has improved, and we're seeing more and more collaboration on our jobs. The team approach to BIM in our jobs, again, theme being collaboration, being improving all the way through. Our design and construction teams are becoming more and more engaged with the process. So what that'll lead me into is a little bit of talk about how AECOM is developing efficiencies through BIM and where we're currently at with our own deployment and development. And also using the case study to, I guess, explore a little bit some of the efficiencies that we've seen go from our design model into a construction phase, which has been great to see AG Coombs and Lend-Lease embracing that and moving forward with that. I'll talk about some of those items mentioned, and then also a little bit about what we see as, I guess, future considerations within the BIM space and design. So I mentioned the case study. This is a data centre project. It's been on site or in design for the last 3 to 4 years. It comprises 2 buildings. Use that laser pointer. So a new energy centre down here. The intent of that was to provide additional power and EPP for the new data centre building back there. So the NEC, or New Energy Centre, it's a high voltage facility, 22 kV, with a 20 MVA HV capacity, which is obviously taking supply in from the utility. It has extremely high levels of complexity with regards SCADA, PLC, and HV protection requirements. It has 10 MVA of EPP, or emergency power generation, and it has an N+1 redundancy throughout all its systems, so highly complex, which feeds the data centre. The data centre, or NDC, New Data Centre, is a facility that's still in construction at the moment. It's 2,000 square metres of IT space at 3,000 watts a square metre of IT and cooling capacity, so it's quite a dense IT environment. Low PUE, 1.3, which is considered a world's best practice, and Tier 3 redundancy. So move on from there. I should mention as well, main contractor Lend-Lease and AG Coombs were the mechanical contractor and also the lead coordinator. And they've really been instrumental, I guess, in taking the lead with regards taking our model and running with it and bringing everyone on board with that journey. So it's been really great to see. So this is, I guess, from our point of view, from AECOM's point of view, what we see is our definition of BIM. There's a lot of definitions of BIM that go around. This one, I think, is quite a good descriptor, and when I hear others and I think about BIM, this comes back a lot, I think. So what we see it is leveraging data created during one task to assist in performing another. Okay, so that really just does describe, I think, all the things that we've been talking about over the last 2 days around using information and work to make the next part of the process more efficient. And I think we find that to be quite a good Now, how do I get on to the next one there, guys? There we go. Okay, so AECOM's approach to BIM during design. So pursuit to a fully integrated workflow. So the way we approach our design is we advocate for open standards through our design phases, and we do embrace the BIM-MEPAUS process and workflow, but we are also mindful about keeping it as generic as we can do in the early stages of design to allow for that changing design going forward. What we do is we're open to sharing our model with the contractors so that, again, they can bring those efficiencies back into that total project. In doing that, we need to consider some of the legal issues. Now, they're not stonewall legal issues. I mean, they're things that we deal with on a daily basis, and typically that would just involve having a consent between parties to transfer digital information. So it's no more than that, really. What we're finding and what we're seeing going forward is the more resolved the BIM model, whether that be AECOM as the designer or anyone else as the designer and the contractor, whoever is bringing that resolution, that level of resolution into the model, is when we're seeing the greater efficiencies being gained. You know, that's true for going from 3D to 4D to constructability to BIM to field and so on. And something that Alex from ProBuild mentioned yesterday around when they decided to take that step in BIM for the New Horizons building, I think resonated with me a little bit. Where they said they received the model and it just seemed a shame not to use it. So that was their impetus to sort of get in and have a go. So, you know, what we see out of that is really, it's very much the quality of the design, the quality of the consultant's model in the early days that really sets the tone for that BIM project success going forward. There's education of the industry to be done. People need to understand where, I guess, levels of responsibility lie, but also what to expect at varying levels of design. You know, people sometimes think that if it's designed in BIM, well, then it's coordinated, it's fully complete, you know, when the consultant's finished, and obviously that's not the case. So what we're finding is BIM-MEPAUS is educating the industry around some of those expectations, which is great. So the next couple of slides, some people may have seen before if they've been to Building Smart or other forums, and I'd reference Russell Strange from our office who put these slides together. And what these slides do is really, I guess, explain again, I guess, our approach somewhat to workflows. So what you can see here, of course, is the original non-integrated workflow that we all used to work through. You know, in the olden days, it's disjoined, there's no linking of phases, it's one leads on to the next, leads on to the next. There's really very little collaboration. And obviously what we're now working through and working towards is, rather than having data as the deliverable at the end of the job, having data as the deliverable as the constant throughout the process. So from design into construction, into commissioning, we've got overlap, we've got all phases and parties inputting into that data deliverable and bringing it together. So this slide here, I guess, just explains that process a bit further in terms of information exchanges. Each of the blue arrows represents an information exchange, so from design to construction, commissioning, and then from each of those individual phases, from design to what the performance needs to be, from the construction into their supply chain, and likewise from the commissioning, getting the commissioning data into a data-rich 3D model. That 3D model at the moment is, in most cases, a Revit model. And what BIM-MEPAUS is doing for us is actually sorting out those information exchanges. So that's obviously a good thing. What we are seeing, which is interesting, is the fact that at the moment there isn't a seamless transfer from the commissioning phase into the asset tracking and facility management. So going forward, you know, there's going to be ways for us doing that, whether that be an open standard, IFC or COBE, to link all the way through to that asset tracking and probably try and achieve that, that nirvana of facilities management, BIM modelling that we've been speaking about the last few days as well. So, again, in terms of our approach, we're constantly trying to find ways of bringing more efficiency into what we do, and also bringing more value into the model that we hand on at the end of the day. One way that we're doing that at the moment is by using this is a clash detection workflow, but with a bit more of a spin. So basically, from our Revit model, we're exporting into Navisworks to run clash detection, which is, I guess, in the normal process that most people would be using. That Navisworks clash detection data is then imported into a report format in a spreadsheet. So what that allows us to do is track on a daily basis in a live modelling scenario the number of clashes that we're seeing in the model through that very detailed design process. And obviously the intent would be to resolve the model to such a point where the number of clashes is well, ideally zero, but then it depends on what you define as a clash to be. But certainly this is a way of us importing that data into an Excel spreadsheet, manipulating that data and interpreting it, reporting back to our design teams, and then using that information to put that back into the Revit model. So it becomes an iterative process for us to, again, just improve the model and bring a higher quality output at the end of the day. This is really just another slide to show some of the ways that we're using Revit and BIM as a design verification tool. So we're using colour to verify parameter contents and fixture placements on drawings. So if we're looking at that drawing, we can see 1100 mil there. We know that those data and power outlets are at the right height. They're in the right parameter. And that can be done very quickly and easily by printing a drawing and scanning across. So again, it's just a way of extracting more info from the model. Saves time for us. We get more of an opportunity to verify the data, and just again brings that value to the process. So I'll probably move a little bit more back into the case study. So the Telstra data centre, again, we sort of started working on that 3 years ago. Was the first job that we really launched into highly collaborative BIM design processes, to such an extent that we actually brought the architect into our office. So the architect sat in our office with us for 6 months. We gave them BIM-enabled machines. We were stationed together. We shared the model on a daily basis. And what that brought was, I think, the highest possible levels that we could get of collaboration. So our engineers, both services and structures, AECOM engineers, and we had our architects from Woods Bagot, who were a sub-consultant to us, sitting with us and working on that model in tandem and in parallel. And that really, that was the highest levels of collaboration that we'd previously seen on any project, and that was obviously being facilitated through the BIM process, which was great. But what that really does, it brings a good design output, but what's really interesting is the behaviours that generates, and a collaborative behaviour and a team ethos really engenders a strong culture for the project and gives it the best opportunity for project success. And that was reflected through the design and then into the construction. The photo there is of the guys at the topping out ceremony of the Energy Centre. That's the design and construction team, which was a good milestone for any project. So with regards to efficiencies in construction phase, again, we shared the model, we shared our design model with the contractors to allow them to bring efficiencies into their process and therefore into the overall project. They were able to bring efficiencies into their processes through measuring and takeoffs and their procurement processes. Obviously the shop drawing process, using our model as the basis for that. Prefabrication has been a common theme today and yesterday, and it's certainly been used on this project as well. and also BIM to field, which I believe is I think as Warwick was saying, one of the first projects that they've implemented their full suite of BIM on that project. It also brings efficiencies to us in the form of less RFIs. Now, and therefore there's variations. The numbers there are quite interesting. You probably might notice a very standout misnomer. The numbers of RFIs are quite low with regards to the mechanical, fire and hydraulic, and quite high with regards to the electrical. What is to remember there, that doesn't mean that the electrical wasn't coordinated or wasn't modelled. That's really a reflection on the level of technical complexity of these projects. They aren't spatial coordination RFIs. These are RFIs regarding PLCs, SCADA, HV, very, very high level of complexity HV issues that we had to work through with both the utility and then the contractor. So, but if you look at the other numbers, mechanical, fire and hydraulic, very low numbers. So that's been a really good outcome. I might mention as well that even in those RFI numbers, that actually also includes technical submissions of equipment for approval. They come in as RFIs as well. So you're always going to expect 20, 30 of those. So if you take those off the equation, it's a very good outcome. One of the ways that we were really happy to see the subbies get efficiencies out of our model was in their measuring and takeoffs in the procurement. AG Coombs basically took our model at the completion of design and at their tender phase and pretty much used our model verbatim for the measuring and procurement process for their pipework. To put into context, you've got 10 megawatts of cooling capacity on that site, which is huge. It's all one central system, so there's a lot of pipework. And what they were able to do was extract those schedules directly from the model and send those straight out to their pipework vendors. They had confidence in the quantities because they'd obviously reviewed and vetted the model. They had confidence in the model, and therefore they had confidence in the schedules. And where that differed from the normal process was rather than sending drawings out to pipework vendors, they sent a schedule. That schedule had no risk being priced into it because it was a definitive number, and they were able to send it out to 3 different competitive vendors to get the best price. So certainly savings, financial savings to the contractor compared to the old method of doing things. The shop drawing process, again for Telstra and other AECOM projects that we've worked with the same team on actually, Craigieburn Town Centre being the other example, the contractors basically used our design model for the basis of their workshop drawings. Those 2 images there are interesting. What you're looking at is the diesel rotary UPSs within the basement plant room areas. The level of services within this would be equivalent to the complexity of a laboratory or a hospital in terms of the coordination. Very dense services requirements. And the redundancy requirements around the data centre environment obviously adds more complexity to that and more density to that as well. What Coombs were able to do is obviously take that. They were converting that obviously to a BIM-MEPAUS format and a prefabrication format. And then using those models obviously for their coordination processes. What we're seeing and what we've seen on other jobs as well is, I guess, which is different to I say the olden days, not that long ago, but we're seeing more regularly very little change in the workshop drawings as compared to the design drawings. Yes, there's the high level of detail that you need from LOD 200 to 300 and so on, but in terms of the layout and the coordination and how things are being put together, we're often seeing little change, which is great. It gives I guess, benefit to the whole process. So these images, they're actually not of the same zone. So don't try and compare one to the other. But what I guess I'm trying to show here is again the levels of complexity in the design and also in the construction. On the construction, you can see parts of Coombs' prefabrication processes coming into the job there, which was great. And if I flick through some more examples of, I guess, what looks like spaghetti junction in the design, again, just showing the high levels of complexity of coordination. The construction model on the right, again, it's not the same area, but just I didn't have the benefit of being able to get one from the other, unfortunately. But again, what it does show is the levels of complexity, both in the design and the construction. So this image is probably, these types of images for me, I think, are probably the money images for the architects. I think we called them Hollywood BIM yesterday. But they're great, I think. It really shows, the image on the right there is the design render. The image on the left is the construction completion. And they are, albeit they're at different orientations of the building, one's a northwest, one's a southeast orientation, you can see the architect's language and expression has been replicated exactly, which was great. Architects get that quite a bit with their modelling. Engineers rarely do, until we do our own renders. So what you can see here is a construction completion photograph on the right, and what the actual design render of that plant room on the left is, and what you're looking at there is basically mechanical extract fans from generator rooms in the basement. So again, that gave us a good deal of satisfaction to see that coming out like that. Prefabrication we've spoken about quite a lot. We know that Telstra has got a lot of benefits of prefab, particularly in the pipework elements. They will also do in their risers. They've got some substantial pipework risers to link generators with radiators on the roof. The prefabrication we've spoken about a lot in terms of reducing site risk, which is a safety benefit, reducing site disruption program time benefits. Simultaneous build, the guys are working in a factory at the same time they're building on site, great program benefits. Construction sequencing, and one of the big things that rings for us is the quality side of that equation. And I guess one typical example is if with ductwork risers installed in a riser on site, the reality is they've got very little opportunity to do their sealing, proper air seals around those ducts in a site situation with constricted site spaces and so on. And obviously in the prefabrication process, you've got 100% quality. They've got the only joins they make is when they bring them to site, which is fantastic. The lower images, you can obviously see their pipework prefab. And I must thank AG Coombs first of all for these images, and also for taking us around the factory. I'd encourage others to look if you get an opportunity. They've got a good operation there. Some other images, I think we've seen these from Peter Doherty and others. BIM to field. So this is this is a field that we've spoken about a lot. This is something that the guys again have taken efficiencies from our model, both in the Trimble robotic point positioning, and also engaging and empowering their site foreman with the technology excuse me, to use on site. One of the good things is obviously resolution of conflict on the site, obviously less arguments. There's always a point of reference, which is the coordinated model to go back to if the fire guy runs his pipe before the mechanical or the electrical or whatever the case may be. Obviously the mechanical contractors have been primarily the lead. It's good to hear Ben's talk there earlier, and we're also seeing electrical contractors starting to engage more in these processes, which is fantastic for everyone as well. Some images there. I think that guy might even be in the audience. The Trimble locators. Obviously the ideal is to position from above the deck. In some cases that may not have been possible, and that was certainly the case in Telstra, unfortunately. But they certainly were able to get benefit from doing it underneath the slab in the lower level plant rooms. I mean, this has obviously been a game changer across the industry for the contractors, so it's great to see it being employed. A few more images there. I think that's one of Coombs' images of the oral hospital. So in terms of where we are as a designer and where we see the future considerations for BIM, we want to see more movement towards the as-built BIM models. We do see those benefits to the industry as a whole and also to the client at the end of the day, if we can embrace this even more, and that's through the whole life of the asset. One of the I guess changes that we need to get our heads around is to actually achieve that. There needs to be an awareness at contract stage that whilst in the MEP side of things, the services guys may be taking a design model from LED 200, taking that through to 300 and 400. It's not the same on the architectural and structural side, which there's a bit of a disconnect there, I think, across the industry at the moment. And I think we need to work together to let our clients know, and there's clients here in the audience as well, that there needs to be a level of understanding that those models do need to be updated through the process, which is a bit of a change to the way things are currently. We're seeing contractors starting to see the benefits of BIM for their own productivity and profitability. And what we have seen, I think on one occasion, and I think we may start to see more of this while we're in this BIM transitional phase, is that the contractors that are able to get the benefits from BIM currently are going to be in a better position to offer lower, pass on those savings to the client and therefore offer a reduced tender at tender stage. We're not seeing that with lead contractors, but we've certainly had some of those discussions with mechanical contractors. And really, I think most mechanical contractors who are embracing this, if they receive a BIM model, they should really start to be able to offer a reduced tender price for the efficiencies that they're gaining. So I'm not putting any pressure on the mechanical guys, but it'd be certainly interesting to see some of those benefits, because I guess that's investment that we make as designers. So it'd be good to see that benefit passed on at the end of the day as well. I think the next part or the next phase from a designer's point of view is actually seeing more of the interface between Revit and BIM with our design packages. There has been a lot of work in this area, and there are some packages such as lighting and daylighting that there is good interface between those technologies. One of the key ones is IES, and we'd like to encourage discussions with Autodesk to try and push forward those conversations and give guidance on where we think some of those improvements and developments can be made. I think if we can do that as an industry, and certainly within the consulting field, we will start to see some of those benefits as well. At the moment, it's I wouldn't say it's disjointed, but there's still a bit of work to do in that field, which is fine. I think that's pretty much the end. Almost. There's another Hollywood BIM image. This is the RMIT SAB project, which I guess was probably one of our first projects that we probably cut our teeth in Revit on. Again, you can see the design render on the left, pretty much the same as the construction image on the right, which again gives a lot of satisfaction to the whole process. So thank you very much.